So it's searching like my database rows, my columns, my names, literally everything. So it can just pick up a bunch of context on what I want. But as you can see, this schema is composed of columns, right? The schema is just like the structure. You can think of schema like structure. And the sleep data is actual queries that are used in order to go and find very specific items. Now, what I do is each night, I have this ring that tracks my sleep, the Aura ring. I've showed it off in a few videos, but that ring tracks my sleep, and I can actually hook this up to an HTTP request and automatically append all of my sleep data to this database, right? And what I have is 5 tables. I have my heart rate data, and this tracks every 5 minutes in my sleep. So it has a timestamp every 5 minutes of every night when I'm sleeping. So this heart rate data has 22,000 records in it. My HRV data, that's the same. It's tracking in 5-minute timestamps. So I have another 23,000 records in here. My movement data, on the other hand, is tracking every 30 seconds, and it scores my movement. You know, it gives it a 2 for moderate, 3 for heavy, 1 for light. As you can see, initially in the night, I'm kind of moving all over the place, but as the night goes on, my movement gets a lot lighter. So every 30 seconds, it's tracking my movement every single night. So you can imagine all of the data I receive when we're talking about 300 nights of 30-second timestamps. This movement data database has almost 225,000 records, and this is just an estimate. I also have sleep sessions and sleep stages to determine whether I was awake in deep sleep or I had light sleep. Also, there's a category for REM sleep in here, so I can really create some awesome data analysis with this. But let's get back to the agent, because with this agent, what I can do is I can actually talk to a Postgres database, and Postgres databases are great for large data with many timestamps. So let me just send off a few queries here so you can see how this works. I could ask something hyper-specific. You know, you saw all the records I have in there. I could ask, what was my heart rate on January 2nd at 4:21 a.m.? And it's going to be able to query my database after searching the schema. As you can see, it's searching the structure of my schema right there. And then it's going to develop a query to give to my sleep data in order to execute it and pull that exact heartbeat that I recorded at 4:22 a.m. Eastern Time on January 2nd. So it said it was 65 beats per minute. I was sick on January 2nd, so my heartbeat was a little high. I could even get a data range, right? I could say, how about for all of January, what was my average heart rate each night? And I'm just asking about my heart rate here. I could even ask about my movement data. Was I moving around a lot at this time, at this night, on this date? Some people might think this is unnecessary, but honestly, where AI is going, you're going to need a database structured with everything. As you can see, it gives me my average heart rate for each night in January of 2025. And now I could even ask some data analysis-like questions. I could say, based on my average heart rate, which nights might I have been sick? I could send that off. And now it can make guesses based on my average heart rate throughout January on which nights I was sick. So January 3rd, it tracked a really high BPM. So that was a day I was sick. I actually got sick twice in January, and the other time was in the back half. So as you can see, it can even track the days that I'm sick based on my heart rate because it knows my baseline from my data, or it can at least get my baseline from my data. So this is AI agent use case number 8, is using a Postgres database and an agent in order to communicate with that Postgres database. But with that being said, that is all I have for this video. I hope you enjoyed. I hope that you learned a thing or two about agents and what you can start implementing in your own workflows.